Now that we've considered how to complete the square, I want to try to complete the square of this equation. ax squared plus bx plus c equal to 0. And before I start, I'm going to give a small disclaimer. I'm going to work through this, and I want you to try to follow along what I'm doing. You don't need to understand every step, but just kind of get the general idea of what it is that I'm doing whenever I do this problem. So first, we have a number in front of x squared, so I need to divide everything by that number, which in this case is a. That leaves me with x squared plus b over ax plus c over a equal to 0. And I'm going to go ahead and subtract c over a from both sides. I then have x squared plus b over ax equal to negative c over a. Now, the next step, I need to take the number in front of x, which is b over a, divide by 2, which is the same thing as multiplying by 1/2, and square it. That actually gives me b squared over 4a squared. So I'm going to add that to both sides. X squared plus b over ax plus b squared over 4a squared equal to negative c over a plus b squared over 4a squared. The left will factor to b over x plus b over 2a squared. And the right, once I deal with common denominators, is going to be b squared minus 4ac all over 4a squared. I can take the square root of both sides. So on the left, x plus b over 2a. On the right, plus or minus the square root of the top, b squared minus 4ac, all over the bottom. The square root of 4 is 2, and the square root of a squared is a. And finally, I can subtract b over 2a from both sides. When I do that, I get negative b plus or minus the square root of b squared minus 4ac all over 2a, which is our quadratic formula. And so I mainly walked through this to kind of show you where the quadratic formula comes from and why it's important that we do know how to complete the square. Without completing the square, we won't be able to get the quadratic formula in the first place. So now that we have this formula, we can use this to solve things rather than complete the square each time. 2x squared plus 5x minus 8. Excuse me. We have x is negative b, so negative 5, plus or minus the square root of b squared, minus 4 times a, which is 2, times c, which is negative 8, all over 2 times a, which is 2. This gives us negative 5 plus or minus the square root of 25. And then negative 4 times 2 times negative 8 gives us plus 64, all over 4. So negative 5 plus or minus the square root of, and then 64 plus 25 is 89 over 4, and I have my answer. My next one, 6x squared plus 7x minus 20. I have negative b, so negative 7, plus or minus the square root of b squared, so 7 squared, minus 4 times a, which is 6, times c, which is negative 20, all over 2 times a, which is 6. So that's negative 7 plus or minus the square root of, 7 squared is 49, and then negative 4 times 6 times negative 20 is positive 480. And 2 times 6 is 12. So I have negative 7 plus or minus the square root of 529 divided by 12. We can actually take the square root of 529 and get 23. So this is negative 7 plus or minus the square, or not the square root, plus or minus 23 over 12, which can simplify. Negative 7 plus 23 is 16, so I have 16 over 12, which is the same thing as 4/3. Or negative 7 minus 23 is negative 30 over 12, or negative 5 over 2. So 4 over 3 or negative 5 over 2. The fact that we got actual fractions this time means that we could have factored this originally, but it seems like a complicated thing to factor, so we just use the quadratic formula. Now let's look at this one. Negative b is negative 3 plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. So negative 3 plus or minus the square root of 9 minus 4 times 1 times 8 is 32 over 2. Simplifying that further, I have negative 3 plus or minus the square root of minus 23 over 2, and we know we can't take the square root of a negative number. So this actually has no solutions, and it is possible for this to happen with quadratic equations.